component of vector A plus C along vector B if A is equal to 5i minus 4j, B is equal to 4i plus 3k, and C is equal to 5i plus 2j. So in this problem, we want to determine the component of the resultant of A and C, okay, the vectors A and C, in the same direction as the vector B, okay, and we've been given the respective vectors A, B, and C. So the first thing we want to do is to find the resultant of A and C, so A plus C. So let's call the resultant of A and C as D, okay. So the vector D is the resultant of A plus C. So in other words, if you add A and C, the result is a vector D. So this will be equal to, the vector A is 5i minus 4j plus the vector C is 5i plus 2j. So this would be equal to, so over here we add like terms, okay, so we add 5i to 5i, and we add negative 4j to 2j, okay, we add like terms. So 5 plus 5 gives us 10i, so we have 10i. Then we have negative 4 plus 2j, negative 4j plus 2j, that gives us minus 2j. So we have minus 2j. So this is the vector D, which is the resultant of A and C. So now the question we can now read the question this way: determine the component of vector D, okay, along vector B, okay, because now A plus C is vector D. So we can actually find the component of D in the same direction as B by using the definition for the scalar product. So let's see how we do that. So we know that if we write D dot B, okay, this is equal to magnitude of D times the magnitude of B cosine of the angle between them, okay. So this is vector D dot B. So the vector D dot B is equal to D, the magnitude of D times the magnitude of B, cosine of the angle between them. Now if we take this term over here, B cosine of theta, okay, if you take B cosine of theta, it is the component of B in the direction of D, okay. So B cos phi is equal to component of B along D. Likewise, if we take D cos phi, it is equal to the component of D along vector B, okay. So in this question, what the question is asking us to calculate is D cosine of phi, okay. That's what the question is asking us to find. It says we should determine the component of vector A plus C along vector B, and vector A plus C is D, okay. So you want to find the component of D along B, and which is D cos phi. So what that means is that we have to make D cosine of phi the subject in this equation. Okay, so we come down here and write that D cosine of phi should be equal to, so we have D dot B, all this divided by the magnitude of B. Okay, alright, so let's compute D dot B. So the vector D dot B is equal to, so we have 10 I minus 2j, so we dot this with the vector B is 4I plus 3k. Okay, so with the dot product, we know that we multiply corresponding things. So we have 10I multiplying 4I. So we have, so this should be equal to, into brackets, we have 10 times 4. Then we have I dot I plus, this is negative 2j. Okay, but realize that there is no j component over here. The j component over here is 0. So we are going to have 0 multiplying negative 2. Then we have j dot j. Okay, then finally we have plus. So if you look at this side too, there is no k component here. So we are going to have 0 multiplying 3. Okay, and we have k dot k. Okay, so if you come down here, we can see that 10 times 4 is 40. We know that I dot I is 1. So 1 times 40 will still give us 40. And over here, 0 times negative 2 is 0. And 0 times 3 is 0. So this side goes to 0. So we have that the vector D dot B, okay, is just equal to 40. Now, the next thing we want to do is to calculate the magnitude of B. So let's do that over here. So the magnitude of the vector B is equal to, so it is going to be square root of the vector B is 4I. So we have 4 squared plus 3 squared. So this should be equal to 5. The magnitude of B should be equal to 5. So having determined this and that, we can now compute D cosine of phi. So now you can say that D cosine of phi should be equal to, so we have, remember it is D dot B divided by the magnitude of B. So this is going to be 40 divided by 5. So we have D cosine of phi. D cosine of phi is equal to 8. So 8 is the component of A plus C, or in other words, the component of D along B.